Good morning, students. Welcome back to Digital Electronic class. In today's class, we are continuing the same concept of K-maps, that is Karnaugh map. We'll take different types of problems for mean term, max term, and we'll try to find out its solution by taking its different problems. In today's class, mostly we are going to cover the sum of product of sum. How do we find by using K-maps? Previously, we have done by using Boolean theorems and Boolean algebra. In today's class, we are actually concerned completely with K-maps. In that, we are taking the first problem in which they are given a function f is equals to summation m of 0, 1, 2, 4, 5, 6, 8, 9, 12, 13, and 14. In this, they ask to find the Boolean function and design as gate level. Means we need to go for designing of its gate level designing also they ask to find and simplify the Boolean function and then its gate level designing. So we need to find out by taking this particular Boolean function. In this, first thing what we have to write f is equals to what is given in that. So what is f value given in this? F is equals to mean term m0 plus m1, m2, m4, m5, m6, m8, m9, 12, 13 and 14. So these are our mean terms they gave. Since the values are ranging from 0 to 15, that means it's a 4 variable K-map. So we are designing 4 variable K-map for this particular problem. So we are designing that one. We'll take the 4 variable K-map. We'll take the pictorial diagram for it. So we have this thing. So we make 4 vertical rows, horizontal 4 columns. We'll make it like this. So we are making horizontal 3 rows. That is 1, 2, 3 and 4 row. 1, 2, 3 and 4. So we'll make 4 rows and 4 columns. We'll try to find out the values for it. So like A, B, and do we have CD? So the combination would be 0, 0, 0, 1, 1, 1 and 1, 0. Here also 0, 0, 0, 1, 1, 1 and 1, 0. So what is the first box represent? Each square box represent one mean term. So I can write this as mean term m0. This is m1, m3 and m2. This is 2 and 3. So like that we are taking 0, 1, 2, 3. Like that next would be 4, 5, 6 and 7. Then 8, 9, 10, 11, 12, 13, 14 and 15. So we wrote all the mean terms. Each square box represent one specific mean term. So we wrote it. Next thing, write down those values. So m0 is there, so it's 1. Then m1, m2. So m1 is also there and m2 is also there. So we have written m0, m1, m2 like this. m4, m5, m6. So m4, m5, m6.Xt m8, 9, 12. So 8 is here, 9 and 12. So 8, 9, 12, 13, 14. So we do have 13 and 14. So we have written all the given mean terms and each square box of that mean term would be 1. If it is max term, then each square box represent 0. So since they gave mean term, so we are mentioning each square box by 1. So now what we can do it, we can combine this 4 and this 4. I can combine. So it's become now one octa combination of it. So I'm combining this all because all are given. So here I can combine this way, this 2 ones, and here I can make this 2 ones by folding. So I can take this 2 and this 2. Total is what? 4. So that 4 is nothing but quad. We are taking the quad combination for that. For this one, what I can take? I can combine this one with this one, or I can combine like this, because possibility of that would be making this 2 and this 2 combination. Again I can make it as one quad. What I'm doing, I'm combining this one with this particular number. So what I got first combination, what I had right now, I do have m0, m1, m4, m5, 12, 13, 8 and 9. In all these things we have to write the common term. So what I can write for the first one, in the first one I'm taking, we do have m0, m1, m4, m5, m12, 13, m12, m13, 8 and mean term 9. So in this we have to write the common. So what is the common in all these things? If I'm taking this box, so I'm taking this particular combination. So in this what I'm doing, I want to write the common. So tell me, if you see row wise, if you see column wise, all are varying. As you can see, it's 0 0 here, again it is 1 1 here. For the next one, if it is next one is 0 1 and 1 0, so all numbers are varying. So in this column wise, all are changing. In the row wise, we need to see. So in the row wise, what is common? C is 0 here, again C is 0 here. That means C is common and D is varying. So what I can write for this? I can directly write as C bar, because only the single term which is common for both the column, if you see in a particular value of it. So if you see here 0 0, here 0 1, that means only 0 is common. That is 0 represent which literal? It is C. So I can write it's C bar. So the first one I have done. Next thing, I can take 1 mean term M0, M4, M2 and M6. So M0, M4, M2 and M6. So in this what I can take common? I can take, so these two boxes I am taking. So tell me what is our row wise in this two? If you see 0 0 0 1, A is 0 0. That means it's nothing but A bar. Likewise, if you see column, this column and this column. So what is the common? C is 0 here, C is 1 here. So I cannot write that particular C because C is changing. Similarly, for the D is 0 here, D is also 0 here. So I can write A bar and D bar. This way I can do it. Or another way, what we have seen, M0 means A bar, B bar, C bar and D bar. M4 means A bar, B, C bar and D bar. M2 means A bar, B bar, C and D bar. M6 means A bar, B, C and D bar. So as you can see, in all, A bar is common, so we have taken A bar. So next way, what is the common in this? D bar is common, I have written D bar. So this is the way also. If you didn't understand how to take the combination, you can go with this method also. So but don't write this way. For your explanation, I have mentioned this way also you can take the common term. For that first M0, M4, M2 and M6. So we took those values, we got the first A bar and D bar. So likewise, if I'll take the next combination, what we had left next chord is what? We had M4. So this next I am taking this one, this 2, and here also we do have next this. So I can write M4, M12, M6 and M14. So M4, 12, 6 and 14. So this we had. So what I can take common in this means just look into these two columns. 0 1 1 1. That means B represent 1 in this. B is common. So I can write it's B. Similarly, if you see the column, so what is this one? First column and last column. This belongs to last column. This is also belongs to first column. So 0 0 1 0. So what is common in this? D is 0 here, D is 0 here. So I can write D bar. So now total what is the function now? Your complete function is changing into by adding these three, by taking this one and this one. So I can write C bar plus A bar D bar plus B and D bar. So we have written that function. So by taking this combination, what we have done? We have find our Boolean function, that is in terms of numbers they have mentioned, that we have made in terms of variables. So by taking the variables, we found the functions. And still what they asked to find? They asked to find by using gate level designing write down. So we'll go for all the basic gates, and not, and OR. By taking these three gates, we'll draw its diagram. So we'll draw here. By taking vertical approach, what we'll do it? We'll take first A, we'll take what is required in this B, then C, then D. We required bars also. What we can write? B, do we have to cut B bar? No. So we'll not go for B bar. A bar is required, so we'll connect one NOT gate. Again C bar, yes, we required C bar, so we'll connect with one more NOT gate. So do we have B bar? Yes. So we connect one more NOT gate. So we are connecting all these gates. So we'll draw it. First C bar, it's as it is. So here into is there. So into means we'll connect with one AND gate by taking the connection from A bar. This is your A bar, and then D bar. So this is your D bar. Then B D bar. So we'll take first connection from B. Then we'll take the second connection from D. So we got this two. Directly we have to take C bar. So where is C bar? Here is C bar. So all these combinations. So we need to connect for OR gate. So we are connecting with one OR gate, you got the function. So we have designed this function by taking f is equals to this 4 variable, its K-map, its simplification and gate level designing. So definitely this question will ask. So we'll see one more problem. So students, so take the next problems. In the next also they give the Boolean function f is equals to a bar b bar c bar plus b bar c bar d, b bar c d bar plus a bar b c d bar plus a b complement and c complement. So they asked to find this Boolean function and obtain by using the basic gates its logic design, and by using the K-map we need to realize this function. So the question is realization of this question. So realization of Boolean function by using K-map and its logic diagram. So we had this function f is equals to they gave. So we need to realize this function f is equals to a bar b bar c bar, b bar c d bar plus a bar b c d bar plus a b bar and c bar. So first thing what you have to do, you have to take this function and we need to take its logic diagram. So before doing these things we should know that f is equals to what is the function is given, a bar b bar and c bar plus b bar c d bar plus a bar b c d bar plus a b bar and c bar. So as you can see the variables are what actually. So here a is there, b is there, c is there, even d is there. That means we need to use 4 variable. So we need to apply 4 variable K-map. To realize this particular function, the first thing what is required is 4 variable K-map. That means for each literals, for each variables, there must be a 4 variable. So in this we had the 4 variable, but here in the first term if you can see a, b, c, only c is 3 terms are there, d is missing. In the second term a is missing, in the last term d is missing. So in order to find that, what is required, the first thing would be the increasing the capacity of that bits we need to increase. So f is equals to what I can write, a complement, b complement, c complement into 1. I can write for this b complement, c and d complement into 1 plus this is as it is. So a complement, b, c, d complement plus a, b complement, c complement into 1. So wherever 1 is there, what I can write, the variable which is missing in that we need to take that one. So what I can write for this, so a complement, b complement, c complement, what one I can write as d plus d complement. So by using Boolean law we can write. So that we have written. For the next term what I can write, so b complement, c, d complement, one I can write it as what is not there, a. So a plus a complement. Similarly this is as it is, a complement, b, c, d complement plus for the last term what is missing, so a, b complement, c complement, d plus d complement. So we have written. So now multiply each with both the factors. So we got it as, we got a complement, b complement, c complement, d plus a complement, b complement, c complement with d complement plus next term. What is the next term we had? A, b complement, c and d complement plus a complement, b complement, c and d complement plus for the next term. So what is the next term we had? This is as it is, so we are not doing anything for this factor because all variables are there. So a, b, c, d bar plus here a, b complement, c complement, d plus a, b complement, c complement and d complement. So what is this first indicates? 0, 0, 0, 1. That means it's what actually, it's a mean term m1. So this is nothing but m1 plus for the next factor alls are zeros. So it is nothing but m0 plus what is this, what is the value? 1, 0, 1, 0. So what is this value? 0, 0, 1, 0. This is 0, 1, 1, 0. So 1, 0, 0, 1. This is 1, 0, 0, 0. So like this. So all complement means it's all are zeros. So we know its respective mean term. So that term, mean term we are mentioning. So what is the next term we can write for this? It's 8 plus 2, it is nothing but 10. So I can write it as m10 plus next I had, this is what 1, that indicates what 0, 0, 1, 0, it's nothing but mean term m2 plus next 8, 4 plus 2, it is nothing but mean term m6 plus 8 plus 1, it is 9. So mean term M9 plus, what is the next term? Mean term M8. So that M8 we are writing here. So we wrote all the mean terms. Next thing, we need to design its 4 variables. For designing this thing, what is required? So we required 4 variable K-map. So we are designing by taking its 4 variable K-map. So we'll take 4 rows and 4 columns. The first combination is what? AB will take here, CD. AB indicates this row, column, CD indicates rows. So what is the first combination we do have? 0, 0, 0, 1, 1, 1 and 1, 0. So likewise here also we'll take, we have taken all the bits. Next, what is this value here? M0. Here M1, M2 and M3, M4, M5, M6, M7, M8, M9, M10 and M11, 12, 13, 14 and 15. So we written all the mean terms. What is required now? We have to write its respective mean terms. So 0, 1 is there. So we'll write 0, 1 and 1 is also 1. Next 10, 2. So we had 10. So 10 is here. We do have 2. We have written 2. Next 6, 9. So we do have 6 here and 9. Next 8. So we made like this. So we wrote all the terms. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So we wrote all the mean terms. Now we need to write what is left out now. We have to take its combination. So how do we take the combinations? In order to take the combination, we'll try to see what possible. Can it be possible to take 8 ones? Adjacent cells of 8 ones are there or not? As you can see here, 1, 2. Only 2 is possible. Here 2 is possible. Here 1 is there. Here 2 is there. So first 8 is not possible because in adjacent cells there is no ones. But I can make it possible to take this and this. By combining this I can make 4. Similarly, by combining these two, this one, by combining this one, this one, this one and this one, that also I can make it as 4 because by taking folding. So corner ones means we can get it. As you can fold anything, all will become at one end. So by taking these corner ones also I can make 1 bit. Whereas this only single one is there. So I can make 2 ones combined because adjacent cell only 1 is there. There is no 1 here. If it is there 1, we can combine these 4 ones. So now tell me how many chords we do have. First is M0, M1, M8 and M9. That is the first combination. Similarly, M2, M0. So M0, M2, M10 and M8. M8 and M10. That I can combine. Next, what I can do it? So this 4 is done. Now only this 2 is left out. So I can take next one, M2 and M6. So I'll get 3 different. So this is what two chord combination, 1 binary combination we do have. So what is actually right now? We need to write its terms. 1, 2, 3, 4. First I am taking. So tell me in this 2, first look into this column. So in this, what is common? B0 here, B0 here. So I can write it as B complement. If you see this 2, now we have seen vertically. Now see the horizontal. 0, 0, 0, 1. Tell me what is the common in this? C is 0, both the ends. So I can write C is common. Similarly, now M0, M2. So M0, M2, M10 and M8. Now we need to look into this corner. Though these are nothing but, this is called it as what? It's folding. So we are using the folding concept. So we need to write this value. Now how we'll see? We'll see again 1, 2, 3, 4. So first row wise, this 2 and this 2. In which way it is there? This one and this one. We have to see first this 2. What is the common in this one? Again B bar is common, so we'll write B complement. Now first column with last column we have to see. What is common in this one? 0, 0, 1, 0. So means D is common. So it is nothing but D bar. So we got row wise this and this come under the first row. This and this come under the last row. That means the first square box and the last corner square box we have to look into it, so that we got this answer of AB. So AB is here 0, 0, AB is here 1, 0. That means B 0 here, B 0 here. That's the reason we got B is common bit, so we can go for B bar. Similarly, the first column and the last column. So what is the common in this? C is 0, C is 1, D is 0 and D is 0. That is nothing but D complement. So in this we found the value of it. So what is left out now? Only one binary combination. So in the binary combination, what is required? In the binary combination we need to write the common term. So what is common in this? So we do have this. So what is common in this? We have to look into row wise. What is the row wise? It's A bar, because A is common in this too. We are taking this binary, and this column is common for both. So I can write C and D complement. So what is the answer we got now? So B complement, C complement plus B complement, D complement plus A complement, C and D complement. So this is our complete answer for this particular problem. So students, so to see the next problem, problem number 3. In this they gave f Boolean function f of a comma b comma c comma d is equals to summation m of this whole 0 1 2 5 8 9 10. They asked to convert into SOP, that is the first bit. In the second bit they asked to convert into POS. What is SOP means? We need to convert that into sum of product. Second thing, we need to write in terms of POS. POS indicates product of sum. So we have to convert this Boolean function into sum of product and product of sum by using K-maps. So the question is, by using the K-maps or Karnaugh map, we have to convert this particular question. So by looking into this variables, you can by default say that it's about 4 variables, because we do have A, B, C, D, that indicates the problem is for 4 variables. So in this what we are using? We are using 4 variable K-map. So first thing, we should use 4 variable K-map and we need to write the functions. So given function f is equals to, we can write mean term m0, m1, m2, m5, m8, m9 and m10. So we wrote the function. So now we'll draw it again, same thing, K-map only we have to draw. It's 4 variables, so we'll draw 4 variable K-map. So 4 variable K-map is means what? We'll make 4 columns and 4 rows. So that we are making, the first value is about AB, second value is about CD. So the first would be 0 0, 0 1, 1 1 and 1 0. Likewise second one 0 0, 0 1, 1 1 and 1 0. So each box represent mean term M0, M1, M2 and M3. Next M4, M5, M6 here and M7. So likewise we'll take next one M8, 9, 10 and 11. Next 12, 13, 15 and 14. So 14 and 15 we wrote like this. So now take the combination 0, 1, 2, 5. So 0, 1, 2 and 5. Next 8, 9, 10. So we take 8, 9 and 10. We combine like this. Again we can combine these last corners once, this and this and this. This all we can combine. So we got all corner 4 ones. So we got the first one M0, M2, M8 and M10. Second thing what we can do it, we can combine these 2 ones, and this corner one and this one we can combine, because it belongs to the same column, same way we can take it. So what is the next thing we do have? M1 and M5. Next one M1 and M9. So we can take like this. So we left with 0 to 8, 10. So 0, 2, 8 and 10. So in this again same way. So here is what? 0 0, here is what? 1 0. That means it's about D complement, that is D bar. Similarly row wise you see, this is 0 0, this is 1 0. That means it's nothing but it's a B complement, because it's B is 0 1 0 0 0 1 0 0 1 0. B is common, so we wrote for these corner ones. Done. Next, by taking those 2 we can take it. So it is what? M1 and M5. Tell me what is M1 M5 combination? 0 0 here, 1 0 1. That means A is common, so I can write it as A complement. Likewise next, so this is same column, so we can write C complement and D. Why we are writing? Because it belongs to the same vertical column, so that is as it is. Next one M1 and M9. So what is M1 and M9 now? So here M1, here is M9. So first column and last column, both are coming on the same way. So first thing is what? C complement and D. Next, looking into these values. So it is 0, 0 in this one. Here is what? 1, 0. So again it is what? B complement. So we wrote this all in terms of mean. So F is equals to what we got? B D bar, B bar D bar plus A bar C bar D plus B bar C bar and D. So we found mean terms. Mean in the sense we convert that particular function into sum of product. Next, what is left out now? After writing sum of product, we have to write its product of sum, POS form. So how do we do it to POS form? To write this one into POS, the same function, what you can do it? You can either complement, you have to take a reverse. Means into will become addition, addition will become into. So here is what in multiplication is there. That I can modify it as what actually? I can write it as B complement will become B. Into will become plus. This is become D. So it is nothing but B plus D into. Plus will become now into. So now tell me what is A complement reverse? It's A. C complement is what? C. D is will become D complement into. Next, what is the next term? B complement, C complement. Nothing but B plus C. Is D is there. That is nothing but D complement. So that particular function we convert into, first bit they asked in sum of product. This is your sum of product. Second one they asked product of sum. We convert into product of sum. On other way, what you can take? You can write the zeros for that and you can get the answer. You will get the same one. So or else, whatever the function is given, we have to take the complement of that. By applying De Morgan's law, if you do it, A bar dot B bar can be written as A plus B whole bar. That way you can do it. Or else, in short, you can remember, if you do have complement, remove that complement. If you do have multiplication, that will be written in addition. So we can write that particular function into product of sum and sum of products. That's how we'll do the problems of K-map converting into SOP and POS. The same function you can go for realization of by logic gates. The one which we have done for the previous one, exactly same. Variables are different and number of gates, what you required, that will be differ. Based upon that, you can take that particular function into consideration while we are solving these sort of problems. So in next class, we completely concerned with solving the K-map for don't care condition. So we do have some problem don't care condition and how the NAND gates, the most important gates what we had is NAND gate and NOR gate. Both are called universal gates. So that gates by doing K-maps will go for logic diagram by using NAND and NOR. Thank you.